All right, so page 141, 142 was what I asked you to work on. So let's run through some of them, see how we do. Stop me if there's anything you need me to go from. So I'm going to do quite a bit of them, even though I only assigned you the evens. So problem number 1, is this linear or quadratic, and how do you know?
Linear.
It's linear. Why?
Oh.
It's not squared, it's just x, right? So on this, if you're solving, you're going to add 24 to both sides, and then divide both sides by 6. So that's how your answer would be. That's your solution. But then problem number 2 is a squared minus 16 equals 0. So this is quadratic because your exponent is the second power. This is also the difference of two squares. So break this up into a plus 4 and a minus 4. And then you're setting it equal to 0, so you're solving each. So this is going to give me a equals negative 4. And this one's going to give me a equals 4. That's it. Okay? That's one of the special case ones. And then number 3 gets a little goofy because it's quadratic because squared is your largest term. But it's not equal to 0, so how do you make it equal to 0? Add 50 to both sides. Good. So you get m squared minus 15m plus 50 is equal to 0. Let's go with our special number. Our special number is going to be positive 50. In order to get to that, same sign. They both have to be negative. And then 5 and 10 are the two factors that multiply to give me 50. Negative 5 and negative 10 add to give me negative 15. So let's just go through our method of factoring. And this is stuff we've worked on. So if I have gaps in what I'm going over, it's because we've learned it. So I have an m in common here. That negative comes down. I have a 10 in common here. So then I get m minus 5 and m minus 10. Both of those are going to be equal to 0. So this is going to give me an answer of m equals 5. And this is going to give me an answer of m equals 10. So there's two answers because it's squared. Is that okay? May I move to the next ones? All right. Number 4, kind of going in order. I'll probably do all the ones on the front first. Skip some on the back. This is not quadratic. It's a third-degree polynomial. But if you want to start solving this, what you have to do is say, okay, what do I have in common between these two, in which I have a 3x? And then if I factor 3x out of 3x to the third, I left x squared. If I factor 3x out of negative 27x, that's minus 9. These are still equal to 0. This is going to give me 3 answers, though. Okay? Recognize that's the difference of two squares. So I get 3x equals 0. So that gives me x equals 0. This one gives me a sneeze that wants to come out. And that one is another sneeze that wants to come out. It's not there. It's gone. Notice the 3 answers. It was raised to the third power, so that's why you have 3 answers. 0, negative 3, and 3. Number 5. I get 2a squared minus a is equal to 3. I want to start solving it, so I have to have it equal to 0. So what should I do with the 3?
Subtract it.
Subtract it, thank you. So I get 2a squared minus a minus 3 is equal to 0. Let's do our magical number. It looks like negative 6. In order to get to a negative, I have to have alternating signs. The factors of 6 are 1 and 6 and 2 and 3. Which of those would work? That would give me a negative 1 right there. 3 and 2 would. So that's a negative 3 and a positive 2. If I add 3 and or negative 3 and 2 together, I get negative 1. So I get 2a squared plus 2a minus 3a minus 3. Factor 2a out of both of those. That gives you a plus 1. That sign has to come down. Factor 3 out as well. So you get that. So your answer comes to a plus 1 and 2a minus 3. These are equal to 0, so solve it. So this gives me an answer of a equals negative 1. This one, I'm going to add 3 to both sides and then divide by 2. Gets to that. So 2 answers. Student asked last period, our answers could be fractions? Yeah.
No.
This is the fraction-based algebra 1, not the non-fraction-based.
Watch your language.
Watching my language.
Number 6 is just done like everything else. Number 6, if I break that down, I'm just going to quickly factor it. So I know I have x minus 9 and x plus 6 is what it would factor to. So this is going to give me x equals 9. This is going to give me x equals negative 6. We're done. Okay. Yes, I did it quickly with the factoring method. Number 7, though, I get 2x squared plus 2x minus 60 is equal to 0. We do have a greatest common factor, so if I divide everything by 2, that gets me x squared plus x minus 30 equals 0. And this will quickly factor to x plus 6, x minus 5. So this gives me an answer of x equals negative 6 and x equals positive 5. Done and done. Number 7 we just did. Number 8. Number 8, you get so moved on quadratics that number 8 actually will throw you for a loop on a test or quiz. Why am I saying that? It's not squared, is it? Won't factor. So let's combine like terms. And then let's start solving it. Add 12 to both sides. Divide each side by 6. There's only a single answer. But sometimes when we throw one of those at you on a test or quiz, it's like you're trying to make it a quadratic. It's not. Watch your signs. So that's the front page. We good? Let's see. Anything sticking out on the back page? Oh, number 11 might be goofy with some people. 2x squared equals 11x minus 12. I want one side equal to 0, so I'm going to make that side equal to 0. So I'm going to get 2x squared minus 11x plus 12 equals 0. And then, of course, you can do your magic number saying, hey, my magic number is 24. Both sides have to be negative. 3 and 8 are the two that work. Give me the negative 11, so that's going to give me 2x squared minus 3x minus 8x plus 12. Factor an x out. Factor a negative 4 out. And then solve it. It's not solved yet, but set each thing equal to 0. All right. 13 and 15, the last two I want to work on. Number 13, we get this is still linear because none of my exponents are bigger than 1. On this one, you need to make sure you distribute the negative 2 to both of those. Combine like terms, so I get x plus 2 is 4x plus 8. Alright, subtract x, so I get 3x over here. Subtract 8, I get negative 6. So I wind up with x equals negative 2 there. Seem okay? Alright, so put a 4 on top of that if you're here. I'm giving you points for it. If you weren't here, you're watching the video. Get it done, turn it into me. Then I'll get the kid that comes back, I didn't hear that part. Wait, he's making fun of me. Joe just met with a student this morning. She told me she selected her college. Going to Michigan.
What you got in?
Yeah.
Unlike two people from Greek then.
So again, don't worry about handing those papers in because I'll just put points in for you. But notes are pretty quick today. We good? All right, so we're going to be focusing on, again, looking at special cases. Special cases are difference of two squares and perfect square trinomials.
Yay.
So we've worked with them. This should be pretty easy, so let's just go through. These will be quick, and I'll give you a lot of time to work on it. So if I were to multiply this out, this would come to x squared minus 16. Hey! I am well. Oh, thanks.
What you got?
Oh, Brian.
Uh-oh. Is this your graduation? I saw a bunch of cops over there. I'm not even judging them. I saw it. Brian.
Attached is 1, 3,
Oh, come on.
Yeah,
We're
baby.
very sensitive about it.
That's pretty cool. All right. Hey, so if I were to multiply this out, where did the plus 4x and the minus 4x go? Where did the plus 4x and the minus 4x go out of number 1? They cancel each other out. Okay? So on this one, this is going to be 9x squared minus 25. If I multiplied my inside numbers together, I would have gotten negative 15x and positive 15x, which cancel out as well. Same thing with number 3. This becomes a squared minus b squared, because my middle terms, when I multiply them, I get a times b, which is ab, and negative ab. So positive ab and negative ab are gone. Yeah.
Would it just be a squared because the b's cancel each other out?
Because if I multiply this out, I get a times a, there's that. That times that's negative b. But if I go here times here, I get negative ab. And if I go here and here, I get positive ab. And those are gone because they're same thing, opposite sign. Then number 4, so these are conjugates of each other. Conjugate is not conjugate. A conjugate is same binomial, one sign different. But this one, we'd have 2 of the exact same binomial. Okay, so if I multiply this out, this gives me x squared minus 4x plus 16. So that gives me x squared minus 8x plus 16. Okay, this one, they're not conjugates, they're the same thing. That gives me x squared minus 6x plus 12. So I get x squared minus 12x. Oh, that should be a 36, excuse me. If I could multiply, I'd be such a better math teacher. I'm not sure how they even offered me a job. They didn't give me the simple multiplication. Okay, so if you have the exact same binomial twice, it becomes a perfect square trinomial, which, if you were to graph this, it would show a bounce on the x-axis. That's where your vertex would be. This one is going to give me 4x squared plus 6x plus 6x plus 9. So that's 4x squared plus 12x plus 9. So we're not solving any of these because we're not equaling to 0 at this point. We're just kind of putting them together. May I move on?
Yeah.
Here we go. Alright, so difference of two squares, the exact same binomials twice, one sign different. The answer to it is always perfect squares separated by a subtraction sign. And then perfect square trinomials, I just say multiply them out. It becomes a big pain when you sit there and say, oh, can I find if this is perfect square or not? So these just do normal. It's nice if you can start recognizing these. Alright, so x squared minus 36 is indeed the difference of two squares. Because x times x is x squared, 6 times 6 is 36. So if I were to solve this, I get x plus 6 and x minus 6. Set it equal to 0, so this is going to give me x equals negative 6. This is going to give me x is equal to positive 6.
Yeah.
I think on yours, did I scratch this out? Back on? So you kind of have that smudge. Okay, so on this one, I'd bring the 49 over. And this right here is the difference of two squares as well, because 5x times 5x is 25x squared. 7 times 7 is 49. They're separated by a subtraction sign. So I get 5x plus 7 and 5x minus 7. Those are equal to 0. So 5x minus 7, so I'm going to get subtract 7, divide by 5. This one's going to be add 7, divide by 5. So you get negative 7/5 and positive 7/5. I only have one slide. Yes.
Back to like number 1, if it's a plus sign, it's not real, right?
Right. Yeah. We'll start getting into that a little bit more as we start closing down the semester. But we'll get there. All right. So this one up top, x squared minus 14x plus 49. It probably is a perfect square trinomial. I would just continue to do it the same way, saying, okay, I know I need to get to positive 49. I know because that's negative, both signs are the same. And this is going to be the 7 and the 7. So if I do x squared minus 7x minus 7x plus 49, and then factor it, and then factor, that's a negative. So that's going to give me x minus 7 equals 0. So my answer here is just x equals 7. So we get a double root. We get two answers that are the same thing. So you don't have to listen once. If you listen twice, you're fine. Don't worry. Panic. Yes.
I'm just confused from the question before when it went into a negative 7 over 5. How did we get there?
You're okay with this and this? So then I go, the next step is this. So you subtract 7, divide by 5. And same thing with that. Cool? All right, last slide, I think. Last problem. Okay, it looks like we have a greatest common factor. I think if I divide everything by 6, including the 0, that's going to give me x squared plus 10x plus 25 equals 0. If you factor this, if I do it quickly, it's going to be x plus 5x plus 5 equals 0. So x is going to be equal to just negative 5 here. And that's all I have for y'all today on the notes. So I want to give you guys, gosh, you got 20 minutes to get a pretty good start on the homework. And I hope you start realizing as the end of the year is starting to get closer and closer, we will start giving you a little bit more time in class to work on stuff. So page 143 and 144 is the homework. Of course, we'll go over it tomorrow. I'll mark it off as well. So that's all I have for you, okay?